Hello everyone, this is Sabita Sankara. Welcome back to the Enterprise Data Engineer interview series. Today interview question is, what is data lineage and data governance? How do you implement end-to-end data lineage and governance in a modern enterprise data platform? And a common follow-up question is, if a business user asks where a particular KPI in Power BI came from, how would you trace it back to the source system? So this is an important senior data engineer question because in a small ETL project, we may only focus on moving and transforming data. But in an enterprise data platform, that's not enough. We need to know where did the data originate, what transformations were applied, which tables and pipelines were involved, which report consume the data, and who owns the data set, who can access it. Is the data sensitive? Can we trust the data? Like all these scenarios, we need to know. And if the source changes, what downstream systems will be affected? So that's where data lineage and data governance becomes critical. So now let's take a real world banking scenario. Suppose an executive is looking at a Power BI dashboard. One of the important KPI is monthly customer revenue, that is $125.4 million, like for example. So the executive asks a very simple question: where did this number come from? So as a senior data engineer, we should not have to manually search through hundreds of pipelines and SQL queries. We should be able to trace the complete journey of the metric. For example, the data originally comes from the CRM system and core banking system. So ADF extracts the data and moves it into Azure Data Lake. So the raw data is stored into the bronze layer. Databricks performs cleaning, joint segregation, and business transformations. The curated customer revenue dataset is then loaded into Snowflake. Then Power BI consumes that dataset and calculates to the final KPI. So the complete journey is source, ingestion, and data lake, thereafter transformation, after that curated data and warehouse to BI. So this is complete journey is called data lineage. So now imagine that the source system changes the definition of customer status. So we need to know which pipeline use customer status, which tables are affected, which data sets are affected, which dashboards are affected, which business users could be impacted. This is where Lineage provides impact analysis. Then now let's understand the bigger architecture. So data lineage is only one component. Around our entire data platform, we need a governance layer. So let's say our platform contains SQL Server, Azure Data Factory, Azure Data Lake, Databricks, Snowflake, on Power BI. Then data governance operates across all these layers. So the first component is the data catalog. So a catalog provides an inventory of available data sets, tables, columns, definitions, owners, classifications, and other metadata. Next is data lineage. So it tells us how data moves between systems. Then we have data ownership. So every critical data set should have clearly defined responsibilities. For example, data owner is accountable from a business perspective. A data steward focuses on data quality, definitions, and governance. So a technical owner is responsible for the technical implementation and platform. Then we have data classification. We may classify information as public, internal, confidential, or restricted. Next comes access control. So we need to ensure users receive only the access required for their job. So then we have data quality, security, policies, retention, and compliance. So governance is not in a single tool. It is not a single tool. It is a combination of people, processes, policies, metadata, security controls, and technology. Now let's go one level deeper. There are actually different ways of looking at lineage. First, technical lineage. Technical lineage answers where did this data come from. For example, CRM customer data, ADF customer pipeline, bronze customer data set, then Databricks silver customer table, then gold customer revenue, then Snowflake, then Power BI data set. After that, executive dashboard. This tells us the physical flow of data. Then the second one is transformation lineage. Now we ask, what happened to the data along the way? Suppose the source contains customer ID, order amount, discount, and order status. During transformation, we might filter only completed orders, join customer and order tables, calculate net revenue, then aggregate revenue by customer. Then the final metric might be derived from those transformations. So transformation lineage explains how the original data became the final data. Then the third one is business lineage. This is particularly important for senior data engineers. Business lineage answers why does this data matter to the business. So here, for example, customer revenue go to sales KPI. After that, executive dashboards. Then after, revenue performance. After that, business decision. So business users don't necessarily care about the Spark notebook or SQL transformation. They want to understand what does this number mean, where did it come from, and can I trust it. So that's the value of combining technical transformation and business lineage. Now let's discuss how we implement governance in production. So the first important practice is data classification. So not every piece of data has the same sensitivity. For example, customer name may have one classification, while social security number, account information, or other PII may require much stronger controllers. So next is ownership. So critical data set should not be orphaned. We should know who owns the data, who manages its quality, and who maintains the technical implementation. Then next, it's access control. We should follow the principle of least privileges. So users should get only the access they need. Depending on the platform, this can involve RBAC, row level security, column level security, masking, or other controls. So another important capability is impact analysis. Suppose a source column is going to be renamed. Then before making that change, we should be able to identify source systems, affected pipelines, affected tables, affected data sets, and downstream reports. This allows teams to assess the impact before deploying the change. Data quality is also part of governance. So we need to measurable rules for completeness, accuracy, consistency, validity, uniqueness, and timeliness. Then finally, we need policies around data retention, privacy, security, auditing, and regulatory compliance. The goal is not to create governance documents that nobody uses. The goal is to build governance directly into the data platform lifecycle. Now let's answer the interview question directly. So if the interview asks, how do you implement data lineage and data governance in an enterprise environment? So our answer would be, in an enterprise environment, I treat data lineage and data governance as platform capabilities rather than individual pipeline features. For data lineage, I capture the end-to-end flow of data from source systems through ingestion, storage, transformation, curated layers, data warehouses, semantic models, and BI reports. So I also distinguish between technical lineage, transformation lineage, and business lineage so that both engineering teams and business users can understand the data journey. For governance, I establish a centralized data catalog, business glossary, ownership model, data classification, access controls, data quality standards, retention policies, and compliance controls. For example, using platforms such as Microsoft Preview, Databricks or Unity Catalog, Snowflake governance capabilities, and Power BI metadata, we can connect technical metadata with business context and lineage. If a source column changes, lineage allows us to perform impact analysis and identify affected pipelines, tables, datasets, and reports before the change reaches production. So, this improves data trust, security, compliance, operational efficiency, and the ability to make informed business decisions. This is very important part. Let me make one distinction because interviews sometimes check this. Then monitoring side, is my pipeline working? Example, pipeline failed at 2:15 am. So lineage here, where did my data come from and where does it go? For example, here start at CRM and closed at Power BI. Mid of the flow, you can see ADF, ADLS, Databricks, Snowflakes. So the governance, can I trust, control, protect and properly manage the data? For example, here, who owns it? Who can access it? Is it PII? What is the business definition? What quality rules apply? How long should we retain it? Are we compliant? So these three capabilities work together but solve different problems. Let's take one final example. Suppose the business says our customer revenue dashboard suddenly changed by 8%. What happened? With a mature enterprise platform, we don't start manually searching SQL code. So we can follow the lineage. We identify the Power BI report first, then find the underlying data set. After that, identify the Snowflake table, then trace it to the gold layer. After that, trace the Databricks transformation, then trace the bronze data, then trace the ADF pipeline. After that, trace the original CRM source. Then we check governance and operational information. So here, was there a source schema change? Was there a transformation modified? Did data quality drop? Or did the business definition change? Or did a pipeline fail or partially load? Did someone changes access or configuration? So these combination of lineage plus governance plus monitoring plus data quality allows us to perform much faster root cause analysis. So the biggest takeaway from today's episode is data lineage tells us where data comes from, how it changes and where it goes. But data governance establishes the ownership, policies, security, quality, classification and compliance controls around the data. So together they create a trusted enterprise data platform. As a senior data engineers, our responsibility is not simply to move data from point A to point B. We need to build data platforms where data is discoverable, traceable, secure, trusted, governed and ready for business decisions. So thank you for watching the Enterprise Data Engineering interview series. I will see you in next question where we will go deeper into enterprise data catalog and metadata management. Thank you.